Okay, well, I think we should do that then. So a very good evening to everyone. It's really exciting to be here with you all. Thank you very much for joining late in the evening, your time, anywhere you are within Australia, New Zealand, or Asia Pacific. I'd like to start with just a quick introduction of the two speakers that will be speaking tonight. Both of them people that I've got to know in the course of my professional and also my personal career. So I'm very excited to introduce Ali Akhtar, who'll be speaking this evening. Ali has about 10 years combination in banking and in fintech, and most recently at Westpac, where I got the privilege to work and know Ali, and prior to that, Credit Suisse and Standard Chartered. The way this started is really Ali, providing us some feedback about his career and what he did as a data specialist and a data scientist, and in the areas of data transformation and cybersecurity within Westpac. And we got so excited that we said, hey, can you please have this meetup and give us some, share your knowledge with the community, which he gracefully accepted. So we're very much looking forward to having Ali speak today. And the other speaker that I'd like to introduce is also a colleague of mine at Elastic. His name is Puddick. He's been with us probably for about almost a year now. But he's a great colleague, very knowledgeable. He also brings about 10 years of experience in banking at Deutsche Bank and Macquarie. And I'm very excited for Mark to share some of his perspectives of Elastic, which he pretty much does every day with our customers. So without further ado, I hope this meetup actually is of good value for your time. This is a beginning of a series. Hopefully we'll be able to sort of communicate more as this series progresses. Probably we'll start in general and we'll go a little bit more specific. But without further ado, let me introduce Ali, and I'll hand over to him to start with his speech.
Yeah, hi folks. This is Ali Akhtar. I had been working in financial services for more than 15 years. I worked for various banks across the globe, including Standard Chartered Bank, Swiss Bank, like Credit Suisse, and most recently Westpac. Just bringing my slide up. Yeah. So can you guys see the slide?
Yeah.
All right. So, yeah. So this is like kind of my background. I started my career in quality assurance, then which included like DevOps, quality engineering, writing processes, or like doing different sort of analysis to improve the processes. And then in test automation, including security testing, software development, like delivering high-speed trading platforms for different banks, and eventually moved into data analytics. Initially, it was mainly for like financial system monitoring. For example, like transaction monitoring for fraudulent transactions. Then when I joined Westpac, I was hired to deliver systems which can do the same things, but for cybersecurity. So it's an interesting thing that I learned that the underlying systems for data analytics are same, and then the requirements of the business use case actually make it very different. Technically, we do the same things, but because the requirements are different, we can shift as a career from various business domains and still be very strong in technology. So the perspective which I'm trying to give here in my series is the same, that if we know the technology underneath and we know the techniques of data analytics, it can be used for the same person as a data analytics person or architect. You can work for multiple business areas. So because it's just the first series, I understand that most of us, or maybe all of us, already understand what is data analytics, but we'll still give some introduction. So what data analytics is, I took this definition from investopedia.com. It simply says that the purpose of data analytics is to analyze the raw data and then abstract meaningful information out of it. So here I will give you one example. For example, let's take an example of a advertisement company. So that advertisement company is supposed to is hired by another company, for example, Coca-Cola, to put their billboard advertisement on a billboard. Now the advertisement company needs to figure out where exactly that advertisement should go in the city area. Uh, so like there are many things they will consider. I'm just giving a hypothesis some as an example. They will first check that what sort of people actually drink Coke. What are their what's their age group? What's their gender? What sort of are they students or professionals, or what are the timings? And once they have identified that particular segment of the data or the information, then they will find out where exactly they live or they work or commute. They might even be commuting more through cars or maybe public transport. So that kind of information is what makes that's what we do in data analytics, finding out using the information as a raw form and then making it really usable for the business outcome. So then the data analytics techniques are there that if we use those techniques, then only we can achieve the outcome which we are looking for. And not only the data analytics can be used for a like a business to customer scenario, it can be for business to business scenarios, and it can be within the organization to support the systems or improve their own processes. Like we do a lot of monitoring just to ensure that our IT systems are also doing exactly what they're supposed to do. So same data analytics, but different business requirements and techniques are very similar. So this is on a high level how actually we do it. So the main thing about is to understand the requirement, and as I just explained it to you, it can be like age based, demography based, income based, or gender based. Um, So usually, like in a data analytics, when we actually try to perform, we try to build up tables in a very simple form. That's the eventual goal. But unfortunately, a lot of times the data is not in a table form. It's in a very raw form. It can be hidden in logs. It can be coming from like hundreds of different systems. Before we actually try to do put into a model, data model, we need to identify what exactly are the requirements and what we are going to achieve from it. Then comes the hard part, the how to actually collect that data. So once we have identified the data requirements, the collection of data itself is not easy. A small company with a small amount of data, maybe just let's say take an example of a startup which has let's say only 100 users. The architecture of collecting data is completely different from let's say a large bank or a telecom company. So although the technique for data analytics is same, but how do we design the system which is collecting that information and bringing it to us is completely different. Once we have got the data, doesn't matter what sort of business use case it is, what sort of company size or the data size it is, then we need to organize it in a form that a human can understand and then perform their duties to extract the meaningful information out of it. At a high level, there are very four basic types. Descriptive analytics. This is to identify what happened over a given period of time. For example, how many people actually traveled in a train which were supposed to drink, which actually take Coke, drink Coca-Cola. That's like a descriptive analytics. On the other hand, diagnostic analytics is something has already happened, and now we are trying to identify how this can be something about like a root cause analysis in a given scenario, or it can be something, let's say, for a weather report, that how a weather affected a beer sale. Uh, we have like storm going on in NSW, unfortunately. So a lot of things are affected because of that. Similarly, in the COVID scenario, there are so many things where executives have to make decision, remote working. Um, and when we say remote working, then it means that our systems, IT systems need to support, should be able to support those. So these kind of things are like in comes in a category of diagnostic analysis. Then comes the predictive analysis, which is very important in case of fraudulent transaction detection in financials and also for cybersecurity. If we are able to detect a pattern, then can we actually predict that what is going to happen in the near future? Which the likelihood of that happening is also another concern. Um, so it's a very generic example is given here. So what happened to sales the last time we had a hot summer? So if, and let's say if this, it can impact the sale in a positive way. It, let's say for an ice cream shop, it can impact the sales in a very negative way also. So the predictive analytics is used for the purpose, so that we either utilize the opportunity or grab the opportunity, or we don't repeat the mistake. Prescriptive analytics is this is where executives make a lot of decision. Um, it's just a course of action that if we do a particular thing in a particular form, then we are more likely to achieve our goal in a better way. And how much better? Um, Again, the same thing, that we either use the negative scenarios and try to avoid those scenarios, or we use the positive scenarios and try to top it up. Um, just moving to next slide. So, so for the business context, so let's say, so like my series is about setting up, just telling you for what I have experienced, and how we are going to, how a data analytics professional can switch career. And also just not in, like, I mean, the just not maybe in financial services or cybersecurity, but also in any other, let's say, telecom or retail industry. But by giving two sort of scenarios which I have personally experienced, you will understand that this is easily doable. um, Eventually what we try to do most of the time through data analytics is make a decision or monitor a particular scenario or a particular business, that is it performing up to the mark. uh, in a cybersecurity scenario, it could be like, have we received any threats, what sort of threats we have received, what sort of threats we did receive but we missed it, what, how many were the red flags, how many were the actual false flags. And also then for executive reporting. For executive reporting, it can be related to financial decisions, that if we have brought in a new system for data analytics itself, did it actually help? Or maybe a cybersecurity system, maybe DLP system, how was our decision really useful or not? Similarly, for financial services, if you take example of finance, it can be related to transaction monitoring. For example, a very simple example that we do every day. Let's say we add a payee in our mobile banking app, a new payee, and our limit for daily limit for financial money transfer is $2,000 or $10,000. A new payee is added, and then eventually immediately all of the limit is used to transfer the money to that payee. So is it a red flag? So what do we do in that case? Shall we actually monitor those things? Can it be a fraud itself? So so similar thing, but now the perspective is changed. And for also, let's say, for executive reporting, or even to make a new financial product, we use a lot of data analytics to find out, like in a particular scenario, a mortgage, a new way of providing mortgage, or trading the mortgage itself in a stock exchange. So those kind of decisions we make through data analytics. This is the statement which I found very interesting. I thought of putting it there. in a very bold way. If you're not properly measuring something, whether it's your weight or the number of defects per million in a production line, it is nearly impossible to optimize it. Like if you take example of our weight, if you keep on eating or not eating at all, or not looking at ourselves even in the mirror, then we are going to make it a very wrong impression or even make ourselves sick. So this is about the business context. The other part which I wanted to tell is that in the first episode of this series is that how do we actually collect the data? So we got the business context. We will be given business requirements, what to achieve. But in order to achieve that, we must have a system already in place, or we must design a system. So we might be asked to actually design the system. And then eventually, once we have designed the system, then only we can make use of it. So if you talk about like getting the data from different sources, there are, whether we use a specialized system, let's say Elastic, Splunk, or Hadoop based or Kafka based systems, or like Spark streaming, eventually underneath this is what is happening. Underneath this is what is happening, which is called data streaming. So data streaming used to happen in, or even today it happens in many different ways. But what the main point is that there are many publishers which are sending data. It can be a static file, that's a simple Excel file, or it can be log file, which is continuously rotating. A new and new data is coming. So it can be that can be another publisher. It can be a system which is continuously generating data, let's say from ATM machine or POS machines or online banking. And in case of cybersecurity, let's say a firewall logs. So multiple publishers are continuously sending data. Then we are supposed to consume that data so let's say an ATM machine is sending the data. The ATM machine's actual data is about the transactions which are being performed. So ATM machine eventually connects with the core banking by going through many different systems. Similarly, online banking eventually connects to the core banking system. Mobile banking, the same, POS machine. So it's the same financial transaction, but going through coming from multiple publishers, but eventually going into core banking system. At the same time, we have other systems which are actually monitoring the publisher itself. So let's say infrastructure monitoring systems, and also cybersecurity monitoring systems. So the similar kind of log with different sort of different type of parsing is sending data to multiple subscribers. So in this example, I just mentioned infrastructure monitoring system, data warehouses, core banking, and then cybersecurity system. So these systems which are receiving the information are called subscribers. The data which is going inside is called message. The message itself has two parts usually. One is a metadata, which is in other words called header, so that we as a human or as a system we can identify what is this message about. So a message is simply like kind of an envelope. The envelope is closed, and envelope has from and to address. So who sent it, whom it is supposed to go, where exactly it is supposed to go, and then when it is received by the subscriber, the right subscriber, they will open it up. So that's what the message is. Many different data streaming systems are developed for the purpose, and the data streaming, like how we do it in a specialized system, Elastic and Splunk, it was happening even before these systems were so much capable, how much capable they are right now. Like in a normal banking system or telecom or any large company, event buses are still being run. And similarly, MQ systems are also in use. Now, since last, I think 4 to 5 years, Kafka has been getting a lot of popularity. The reason of moving from event bus to Kafka is a separate topic, which I will discuss in the next session. At a high level, very, very high level, in a message bus or event bus in MQ systems, the number of, the, there is, if let's say there is only one topic, and that topic is talking about, um, let's say, firewall data. So that topic is supposed to be received by multiple subscribers. In a normal MQ systems, the subscribers will have their own specialized queue because the subscriber A and subscriber B do not run at the same speed. They have their own capacity. They need their own queue so that they can read the same message, which is a copy of the other message. Uh, but because they are running on a very different pace, if we put only one queue, they are not going to. At least one subscriber will miss the message. So when Kafka was designed by LinkedIn, they uh, they had, of course, the same problem also in hand, but they also have the MQ system problem itself. So when we have a lot of multiple queues for the same topic, so let's say two queues, uh, even though that we solve the problem that let's say subscriber A is fast and subscriber B is slow, still because it's very slow, the size of the queue is limited. It gets piled up. That's where the Kafka was designed, that instead of having multiple queues, why not make the topic itself a queue and make it so large, so much replicatable that even the slowest subscriber can cope up with the speed. So as I mentioned, it's a very different topic, which I want to discuss it in detail in a different slide, in a different episode. So I will just move on to a little bit to a specialized system because we are in Elastic meetup. I just took the diagrams from a website uh, for Elastic. So I won't be discussing other systems. In the end, all of the systems that I have mentioned here, Elastic, Splunk, Palantir, at a high level, they all work in the same way. And because the technology is different, the interfaces are different. So we must learn those systems separately. But at a high level, it's same thing. Uh, what what we do is we collect the data. To collect the data, there are many different uh, in Elastic Stack. There are like two things. Are you guys able to see my screen? Yeah. Okay. I
Yes.
had a sort of glitch here. So in case of Elastic, like the data collection and the parsing is part of the log stash, and they also have Elastic Beat, which is a small agent which we can put in the source systems, so that we don't have one large scale system just pulling out the information from the source system. And then uh, once the data is taken out from the subscriber, either the publisher. If the publisher is pushing, doesn't matter if the publisher is pushing or the log stash is pulling it out. It doesn't matter. Once it is in log stash, we will be transforming it, writing scripts. Once it is transformed in a little bit raw form still, we will put it into a system called Elasticsearch. The purpose of Elasticsearch is to store the data and make use out of it. There are so many different use cases for Elasticsearch which are not related to data analytics. So it's a very powerful tool. I have used it for just for synchronizing application servers itself. So because application servers are very independent, the only way they talk to about in a older way, in a very if you say that in a very established way, they only talk about the data, talk to each other through the database. So let's say a message is coming that it transfer the money from pay one to the pay two. The message itself, that transaction, the HTTP request can go to via the load balancer, can go to any of the system. We can control the load balancer also, but the system can also fail. In what will happen to the transaction which was happening? So in that case, we design the application servers in a way that they talk to the database and then know the state of the transaction, what is happening. I have designed a system where we actually use the log Elasticsearch itself to so that these can talk to each other directly, because it's a very high speed. Instead of database, it's like you can index it in memory also. So which has not, so this scenario which I just mentioned has nothing to do with data analytics. So that I was just trying to explain the power of Elasticsearch. In our case, like in this, for the purpose of this slide, the Elasticsearch is used as a data store to store the information which we have collected and a little bit transformed. The reason I'm saying a little bit transformed is that because Logstash, we can't view the Logstash system, we cannot see the information. So either in a development scenario, we will still be putting in Elasticsearch and use Kibana to visualize what was coming through, have we achieved the transformation, or in a production environment, the same thing is, so Logstash, Elasticsearch, Kibana in a production environment, a very established data transformation and analysis and visualization has like we can actually fully use it. So in a development scenario, we use the three stack things: Logstash, Elasticsearch, Kibana, Elk stack, to visualize and redo the same job so that we are sure that the executives are getting the right information. In a production environment, the same pipeline is not touched. The only way we touch the same pipeline is go back to the development environment and try to improve what we have established. Um, so this is kind of the end of my today's presentation. In the next lessons, what I'm trying to do is that I actually get a proper business case, both for financial services and cybersecurity, and then explain, and also so because this is going to be multiple of the sessions, I will also explain the difference between normal MQ systems and Kafka in a great details, so that you guys can understand and should be able to write or design a architecture based on Kafka or MQ system, which is not just limited scale but global scale, and the reason why would you choose one over the other one. And eventually what I'm trying to do is that establish that the two sample business cases and run those business cases on Elastic and show you that how it is being done, which will not include how we install Elasticsearch or Elk stack, but how to make use of out of it. I would definitely touch the architecture a little bit, but it will be more about how and how the data is parsed and why it is parsed in a way, what are the requirements, so those kind of things. So this is the end of my session, Nidal.
That's very intriguing, Ali. I really appreciate you sharing that. And to be frank, I'm looking forward to the sequence where we can you can take us on this journey and probably explain to us how, in a banking environment, you can extract value out of your data, a true demonstration of data analytics in many ways. I'll open the floor for questions. Anyone has anything for Ali before we move on to the second part and the second section with Mark? I think most people are muted, so cannot ask questions directly. So if that's the case, we might probably leave it to the very end. But Alicia sent a question.
Yeah.
A very good one, very topical one. How difficult to find money laundering with analytics? Great question.
Right. So this is an interesting question. First, we need to understand what is money laundering, how people actually do money laundering. It's a very complex area. At a very high level, so I got trainings from different banks. I don't want to name that those banks. So like in a very rough idea on a high level. So when somebody is actually doing money laundering, they do transaction wrapping. That's a term. If you want to Google it, it's called transaction wrapping. So they will most likely open up companies. It's not a personal thing. Companies, shell companies, countries, and then purchase items, maybe a lot of Mercedes-Benz, and then sell it. So and then sell it to another company. Sometimes jurisdictions are so much well established that finding the money laundering becomes, it can be achieved, but the laws of the other countries are so are designed for that this cannot be, those people cannot be caught. So if you want to study more about money laundering, try to see what is transaction wrapping and how people do it. In case of terrorist financing, it's a very similar thing. Very similar thing. They use the same technique. The purpose of laundering. So when you say terrorist financing, that's the purpose of money laundering. And when you say money laundering, that is the activity they're doing. So money laundering can be used for terrorist financing, for abuse like child abuse, or many other things.
Have a read, Ali. You can read those, the response from Alicia, right?
Yeah, yeah. I will take it as a comment.
Yeah, I mean, anything from anti-money laundering to financial crime to fraud and to all this is very topical at the moment. We're involved in a number of projects in the market now with some of the big banks about this. We can't speak about it, but usually this is one of the most hotter topics at the moment. The way Elastic is involved in this is really in fast search and speed of search and relevance of search, particularly when it comes to amazing number of sources of data. But I don't want to hijack this meetup. This is a very exciting topic that probably would have its own sort of session. But I wanted to thank Alicia for the questions and the comments there, and probably for in the interest of time and getting some we'll move on to Mark Puddick. So Mark, I'll hand over to you, but thanks to you, Ali.
All right, so my talk's going to be a little bit different from Ali's talk. I enjoyed Ali's talk; it was really good. But mine's going to be a lot more probably Elastic focused. So we're going to go through some one of the new features that came out in 7.11. So let me, which is now going into GA actually in 7.12. So we're going to do that, and we're going to have a little demo. This is going to be a little bit different from the normal type of demos you probably see from sort of different subject matter. All right, so let me just share my screen and we'll get started. Let me just double check I'm on the right window. I think it's that one. Okay, can everyone see this? All right, so we're going to talk about runtime fields. So they went into Elastic in 7.11, and they've just, as I say, they've just gone GA in 7.12. So a little bit about me. My name is Mark Puddick. I'm a solution architect. I've been at Elastic for about 9 months. I think Nadal already mentioned this. Before that, I was at Pivotal and VMware for 4 years, then Mongo for a little while. I ran a business for a couple of years, and then previous to that, I was in banking and a little bit telco as well for a long time. So it's Nadal, I think, said I worked in Deutsche Bank in London. I ran their foreign exchange team for about 3 or 4 years with all their foreign exchange and trade capture, which was a pretty exciting role. But this talk is not going to be about banking, so we'll get on. So I think you guys, you probably already, most people in the call, I should imagine, would have already used Elastic in the past. And as you're probably aware, it's schema on write, and that really helps us with the speed, scale, and relevance. So, it's best for data that you understand and that you use a lot. And because you've got that schema on write, that allows us to be very optimal around how we search for things and how we run our analytics and that kind of stuff. So, historically, that's where Elastic's been really sat well. But in 7.11, we introduced some stuff which is moving us a little bit, not moving us away from schema on write. That's really probably still going to be our primary focus. But we're going to also have a bit better schema on read functionality, and that gives us a lot of flexibility, right? So it's going to give you a lot of flexibility when you ingest new data sources, how you handle changes, and how you enable new workflows. So the way that this works within Elastic, as I'm sure you've already guessed due to the talk title, is that we've introduced runtime fields. So runtime fields are fields within Elastic that we can set based on various things. So we define it from a script. We're going to demo this hands-on as we go through. But it's defined by a script. We can use painless. We can use Grok or regex. You can even use dynamic lookup on this as well. So that's how you're going to get these new fields in that are basically generated at runtime. And I'll explain a little bit more about what that means as we go through. They're evaluated query time, so you can actually add them into your mappings as you would any kind of other field type, or you can provide them with a query as well. So what I'll show you when we do the demo is we'll test some things out on a query, and then we'll actually put that into a mapping, and then we'll do some things. We'll do some visualizations and things like with that data afterwards. So it works like a regular field. You can search it, aggregate it, visualize it, just like it would be a normal field in Elastic. So, you know, it's a good way to get that extra information, and it can be used to transform and enrich. So for instance, you know, if you've got some data that's in there, you've maybe imported it as a couple of text fields or something, and you want to take some data out of that, you can do that and bring it in and bring it to a new field that you may, in this example, you may actually convert like a string into an integer or something like that, but, you know, a few other bits and pieces. You can see that it's good for what we said before, the data sources. You can see here there's a little example, that runtime mapping, where we have like a day of the week. So we've got a type on it, which says what type we're actually going to make this field. And then we've got that source script to see how that works. So you can see this one's really simple. It just does emit, and we take the timestamp, we take the value of that, and we get the day of the week. So very simple to do. And we'll show you, like my example that I'm going to go through is, again, very, very simple. We're just going to take some data that I've ingested, and we're going to just put some extra things on that so we can visualize that in a field. We'll get through. Okay, so we've got some use cases here. So we've got adding new fields to index. This is more the dynamically created fields where we can actually set things up within our mappings that are then they're not actually indexed, so that's going to stop you using up index fields, and it's also going to reduce the amount of overhead you have in storage and things like that. So that's one thing you can do with it, and I'll show that. I've actually got that mapped with my example, and so, but it's not probably the key thing. We can use ephemeral fields here. And that's defining using fields within the context of a query. So we will demo this. This is basically, you know, what we said in the previous one. We can do a query, and we can add on to that a runtime field, and we can define what's in that runtime field. So we can say, for this field, we want to do, you know, some calculations or whatever, and then we can adjust those, and we can run that query again, and we can adjust that and adjust it, and then, you know, we can add that to the mapping. And then once we've got it in the mapping, obviously eventually we probably want to then put that into an ingest pipeline, so that when you actually ingest your data, you do that transformation of that data or whatever you need to do with it, or so you're effectively writing it into the schema when you ingest the data. So in longer term, and then you've obviously got the efficiencies. You go back to the, you know, the schema on write efficiencies that you would get. It's also going to allow you to do things like fixing errors in the index. So if you've got some field that's maybe an error, it's been parsed incorrectly or something like that, you can have a shadow index on there. So it's basically a runtime field that will override a field that's already in your data. So that will allow you to potentially fix some errors in a short term. You know, maybe when you roll over that index, you'll actually fix it in the ingest bit. So that's another use case we see for it. And iterating during data preparation is really, and we'll show that as well, really is, you know, running that through, for instance, in the ephemeral query and adjusting a couple of things within that just to get things where you need to get them. So you can kind of test things out a little bit easier than you normally would. Okay, so you can set all this up in runtime fields, and you can set this up in the in Kibana. We're not going to set up in Kibana today. We're actually going to go through and just do some stuff in DevTools. So we're going to do some quite hands-on stuff just so we can see a little bit more detail about what's going on and what happens. But you can run this through in the UI, very simple to do. And you can log into your Kibana and look at that now. Obviously, that's in 7.12. So we're going to we're going to do a little bit of demo now. We're going to go through an example. Now, I've got an interesting example today, which is probably going to make most people laugh. We're going to talk about go-karting in this example. So I don't know if Nadal's watching, but I work with Nadal, and I talk to him about my son's go-karting all the time. One of the things that I get from my son's go-kart, my son's 11, he races every sort of other weekend, is we get a lot of data from the go-kart. And I've started recently to take some of this data and put it into Elastic. And I thought there's a really good use case for runtime fields with this. So I thought we'd build this out today on this call just so you can see it. So you can see here in this little picture here, we've got a picture of the go-kart. We've got lateral, we get from the GPS, we get the lateral acceleration, so that how much it's moving from side to side, or how much it's pushing from a G-force perspective. And we get the longitude acceleration as well, which is when you brake, pushes you forward in the seat, and when you accelerate, pushes you back. And I've put on this map here, there's two little red spots on the track. This is where they brake on this track. There's only two places they actually brake, and there's this orange place where if the track's not good or the tires are a bit old, they'll brake there because they're doing about 90 to 100 kilometers an hour at this point, at that orange point. But they can still get around that corner without really braking. So we're going to look at the two braking zones, because one of the things with the go-kart, when the kids are learning to drive them, they're taught not to turn and brake at the same time, because it's got a fixed back axle that'll make the back end slide out. So very important that they don't do that. They lose a lot of time. So what we want to actually do is take this acceleration when it's braking, so we can see when they're braking, we can see when they're turning, and we're going to try and work out whether or not they're braking and turning at the same time, right? So what we're going to do is put an extra field in that we can see if they're braking and turning at the same time. So let's go in, and I'll switch over now to my Kibana, and we can start having a look at that. Oh, it's not the thank you slide yet. Okay, so we're in Kibana here. I've already imported the data in, so we'll have a very quick look at it and discover here. So I've still got it, it's in here. So we can see here we've got some data, and we can see what data we get from our computer on the go-kart. So we get acceleration data, we get a load of GPS data, we get some lap data and a few things. We get like speed, for instance, is up here. So I think on this one, he would have been doing 83 kilometers an hour when this sample was taken. We get 50 of these samples a second. So we've got a 50 hertz sample rate on it. So we're getting a bunch of basically IoT data in, and we want to do some analytics. We want to do just a little bit of, but we don't get some of the stuff we want. So we kind of want to do some runtime analytics just to see what's going on and see if there's some turning and braking at the same time. So we're going to use, as I said, these GPS lat field and this GPS long field to calculate this. So what we'll do is we'll go into the dev tools, and we'll start going through what you would do with your index. So this is my normal mapping here. And I've got a couple of things in here that are relevant. We've got a dynamic runtime environment. So all the fields that we're not really looking at, I've actually just put in this runtime field, so they won't be indexed, but so we're not taking up any extra space and stuff. I'm not going to do anything with those for this demo. Normally with this data, I would actually probably map everything that's in there. But this is the sort of dynamic runtime field thing that I was talking about earlier in the talk. We are going to look at some other properties though, then we want these as floats. So we've got distance, we've got RPM, we've got GPS speed, we've got latitude acceleration, longitude acceleration, which are the two things we're really interested in, because we want to look at some thresholds in those and work out another field to see whether or not we're braking and turning. So what we can do with this, which is probably an easy thing to do just to start with, is just have a quick look in Lens. We can just graph some of this data out for us, right? So we'll go into Visualize, and we'll create a new visualization, and we'll go Lens. We are going to put on our horizontal axis, we're going to put timestamp, and we're just going to look on our vertical axis at the, as I say, these two fields that we're really interested in, which is the latitude, and we're going to have a look at the longitude, and we're going to do a line graph on that so we can see each here. Now, this is actually We'll zoom it out a little bit. At the moment, we're actually quite zoomed in just to one lap, so I was testing it earlier. But we'll go out a little bit to maybe that, and we'll just, I think that's, so this is our test session. I think there's 12 laps or something in here. You can see this data in here. And it's quite zoomed out at the moment, so it kind of looks all a bit squiggly. But what we can also do here, we'll look at lap. We'll look at one lap. We'll look at lap 3, because I know there's some interesting thing going on here. And we'll just zoom that in quickly. Okay, so this is our lap 3. Now, you might be thinking this is all squiggly lines, so I'm going to explain this to you the best I can on a call. So you can see here, there's two bits here. Or if you remember earlier, if we go back to the thing, there's 2 breaking points. So we'll go back to this one. There's one in turn just before turn 2 and one at carousel. And you can see these breaking points here. This is where the sharp downturn, because as you can see, we've got negative longitudinal acceleration, so we're getting pushed forward in the cart. And it's the same here. So that's the one up at carousel. That's the 2 points where, you know, there's braking. And you can see here, there's turning on here as well, because there's acceleration to the sides. So what we want to actually do is look at this and figure out whether there's a brake and turn at the same time. So what we can do is we'll zoom into turn 1 and we'll have a look at it. So we can see here, brake, and there's actually a little release of the brake and another brake. But you can see here, the turn turns down. So we're definitely turning and braking at this point here. So if we hover over this, we can see average GPS speed, longitudinal acceleration, -6. And then the other one is minus, and the turning amount is about -1. So there's our base threshold. So what we'll do now is we'll go back to the dev tools and we'll just set up a little, we'll just set up a, we can leave that. And we'll just set up a query where we'll pass in those parameters. So let me just get my notes up on the other screen. Okay, so what we're going to do is we're going to do a query, as I said, we're going to do search. So we're going to do search here. We're going to do a runtime mapping on the search. So we're going to set up our runtime mapping and we're going to call it break and break turn, which is my new field name that I've just invented. So we'll copy that in now. Right, and we actually got a double return type here. We probably could do a Boolean, but the reason I've got a double in here is when I was playing with it earlier, I was trying to get a value that was kind of a probability, but then I thought, actually, you know what, we'll just do binary for the day once, a little bit easier. So here we go. We've just done this really simple. So we've got a little painless script in here. We're just seeing if the longitudinal acceleration is less than -0.7, which we saw from the previous graph. And the lat one is -0.2, then we'll emit 1, otherwise we'll emit 0. So we can do that. And then what we'll now do is we'll just do the query on that as well. Pretty easy. So just do that one here. Sorry, I lost my mouse. So what we've done here now is we've got the little query on here. We've got a match if break turn, which is this field that we've generated in the runtime here. If that's 1, so if we've detected something, we're going to bring back a result. And we're going to just bring out that field there. So let's play that. Let's try that query and see what we get. Oh, that happens better if I select it. Okay, so we've got 43 returned. So we've seen 43 instances where that's happened, right? Now, some of these will be in the same lap. So you can see lap 3. Lap 3. We can probably tune this down a little bit. So, and this is where it becomes really good, right? Because now we can just go in and we can change that field to that. We can do the same, right? We're now down to 22. We might just tune it a little bit more. So we'll put 0.5 in there as well. And we'll do that again. And we've tuned that down and we've got now 11 results. That's probably good enough for this demo. So we'll go down, and what we'll do now is we'll just add that mapping into our mappings, right? So if we just and I've just got this here, my cheat sheet. In fact, what I'll do is I'll do it this way. It's a little better. So what we're going to do here is we are going to we're just going to put in here in our mappings. We're going to add a runtime field. And the runtime field is exactly here, right? We've already done that. So we're just going to cut and paste this in. We can paste it from here. And there we go. I think we've got the right number of brackets. No, I think we've got one extra one. So we'll add that in. Oh, got an extra couple of spaces in here, so we'll just take those out. Oh, something's not going on. Something's gone a bit funny here. Oh, I think I'm missing the bracket. All right, play. So we've now added that field. You can see we've got that acknowledged. So we've just added that as the runtime. So if we actually look at our mappings now, I think we'll probably see it in the mappings. Yeah, so you can see our runtime mapping here is now as part of our mapping. So if we now go back to lens, right, we can actually go and look at this in a little bit more detail, right? So there's a couple of things we can do now, right? So we can go back into the visualization. We'll go back to lens. We'll start and we'll do the same thing as we did before. We'll just take the time, drop it in. It's our bottom field. And what we'll do, just to make it simple for this one, we'll just take, again, we'll look at the same two fields that we've used for the calculation. So that's the same thing. We'll just zoom it out a little bit again. So we'll just zoom it out to 1:30, 2 o'clock. It's probably, and I'll just, so there we go. We've got that here. That's our lap. So that's the multi-laps that we've got. That's the whole session, but we're going to go again. We'll look at lap 3 just to see if we detected it properly in lap 3 and what we can see from the view in lap 3. So we'll go in there. And we can see, we'll just do a quick test. So we can drop on this break turn field. That's our runtime field that we've created. We'll just drop this one in. Rather than doing average, I think what we'll do is we'll just do maximum. I think might make it a little bit more highlight. And you can see already we've got this red peak here, right? So basically this has detected it for us now. So we built a little detector with the runtime field, really simple. Now, what we can also do with this, if we just clear this off, if we just leave that on, but we take these off, we can actually just have a look at, take these two off. We can put the laps in here, right? And this will show us which lap we're on as well. So we've now got, and we'll do maximum again, a lap. Yeah, so we can just, we'll just put the lap counter on. This is kind of a little bit of a funky way of looking at it, but it does work. So we can actually go here. Oh, on this one, we'll go again, we'll go 1, 2, 2, update. And we'll take out the lap filter this time because we want to see all the laps. We'll update and we'll zoom in. And now you can see, we can actually look at this and see, which is really nice. We can actually now see that, oh, I didn't want to do that one. We can actually now see that there's been all the times that there's been turning and breaking at the same time. So we can actually see that, which is generated as a runtime field. We can see that on lap 3, lap 7, and lap 10 and lap 11, we've had that issue. So obviously we go to speak to our driver and say, you need to, fix your turning. So that's basically what we've done. So we've built that out quickly. And that's just a really quick overview of how the runtime fields work. So that brings me pretty much to the end of my little talk. I'm happy to take any questions if anyone's got any. I'll stop my sharing. Cool. Nadal's apparently saying that this is my retirement plan. I think it's eaten my retirement plan, the cost of it, actually.
We should do a return on investment analysis for you, Mark.
I don't think we want to do that. It's not a cheap sport. So
I'll tell you what, I just want to thank you for both presenting tonight. I mean, I wish these calls didn't have mute for everyone. We can be a little bit more interactive. But I'm looking forward to the sequence as well. And I wanted to, take the time and acknowledge everyone and thank everyone for joining wherever you are. I know there are people around Asia, New Zealand, and also in Australia. thank you so much for joining this evening. We won't keep you too long. If you have any questions, please send them through. Really good talk, Mark. Command the length to support runtime fields. Nice, excellent. Thank you for that feedback, Michael. But you don't get a prize from us, Michael, because you're an elastician. But wanted to thank everyone for joining this evening. We really appreciate it, and we look forward for you to tune in. There's a feedback form that was sent in this chat over here. Feel free to send that feedback. There's also a couple of prizes that you might win, which look really handy. So Michael, you don't qualify for those prizes either. Without further ado, thank you so much. Please keep tuned into our community pages to see when the next event is on. And I really sincerely hope this was a very good value for you. Have a good evening, and we'll see you next time.
Thanks, everyone.
Thanks, everyone.